Hello. So I think we started. Okay. All right. So today we'll be talking about the tutorial three. So there are six questions that is actually covering two different chapters. Okay, including the chapter 4 and also chapter 5, if I'm not mistaken. Yeah, chapter 4 and chapter 5. Question 1. Explain three relevant features that an identifier should have for big data resources to operate effectively. So if you still recall, they have a specific slides, okay, talking about what are the features it's supposed to have, and there's actually 10 different features. So try to relate to your scenario. I mean, of course, over here, we don't really ask you to provide a real life scenario, but if it's so, then you can actually try to put in your scenario, like what you have investigated in your assignment, okay? Then you try to see what are the relevant features that actually really apply in that particular company that you have investigated before. Then you'll be able to better explain these questions, right? Then second, identify an example of check identifier, explain how the identifier is designed. So in the class, I'm giving you an example of, I think there are two different examples, but and then I also verbally explain the examples in terms of our IC cards, okay, identification card, and also the metric cards. Okay, all this can be an object identifier. And how, I mean, you're supposed to know how this object identifier is designed from the beginning until the end. Okay. Of course, even the bank accounts can be an object identifier as well. So it really depends on how you want to choose object identifier and how good, I mean, how well do you know that that particular identifier is designed, or else you have nothing to explain. Like bank accounts, if you don't really know their rationale to design it, you can't really explain much. Then the third one, the third questions, explain how one-way hashes can be used to perform de-identification and re-identification and object identifier. We still recall one-way hashes is actually changing to I mean in the one direction, okay, from the original object identifier that might have some PPI, personal identifiable information. Once you do a hashing, then you actually convert into a random string that you will no longer able to know the original information anymore. But how are you able to, I mean, from here, you'll be basically doing the de-identification. But for you to achieve re-identification, basically is as long as you have a lookup table from, the first thing is you need to have the idea what is the original object identifier first, and then you also perform the same way of hashes. Okay, in that case, you'll be actually able to build a lookup table. So as long as later on when your information coming in, even though it's actually hash, as long as you have the hash information and match back to your own hashing lookup table, then you'll be able to retrieve the original object identifier and eventually find out the person that is actually owning this particular data, okay, or contributing this particular data. Then the fourth, differentiate between classification ontologies by using appropriate examples. So this one is actually quite straightforward. As in classification, just one parent, and then ontology, you get multiple parents. So how are you able to highlight these differences using examples like different object classes or the design of the particular attributes, relationship or similarities? How are you able to join it together in ontologies, but how are you able to only use relationship in classification? Okay. Then, because we are talking about differentiation, we are not talking about similarity. So differentiation, then yeah, this is the main differences. Then, explain a potential problem if an ontology model is overly complex and if the classification model is overly simple. So this one, we have two different sections, okay, that explicitly talk about this matter, so I will not repeat it again. You can go back and check your slides. But there are some general concepts that will be, even you don't go back and check your slides, in terms of logical understanding, you'll be able to know, like classification model is always simple, then basically you can't really able to classify or in a very, very fine manner. For example, yeah, that is the example that I actually recall from the slides, I believe. Then the last one, to discuss two disadvantages to use traditional file system in transactional processing. So this one related to the one that we have discussed just now. which is traditional file systems. And remember, we actually have a few different kind of discussion. One is traditional file system, like what we have using like File Explorer. We save the data in folders by folders, and also transaction. And then the traditional database we are using like MySQL or Oracle. And then there's also one more is we are using traditional file access. Traditional file access is a bit different. They're actually using physical hard copy. Physical hard copy to save the data. So these three different point of views, how are they actually having their own advantages and disadvantages? So yeah, so this is how your tutorial is supposed to look like. So, and this week, remember, Friday you're supposed to submit your assignment. Your assignment link, the submission link will be available very soon. I believe it will be tomorrow. And also, some of you did send me the draft. I will be reviewing it by tonight. Then you'll be able to fix it for the next 3 days. If you still want to send me draft for the rest of the groups, please send me by tonight because I will not have time to review the draft after today. So if you can, you send me tonight. Maybe tomorrow morning I can still spend some time with it, or else you just wait until Friday and submit the final version. Okay, thank you very much.